Afternoon, and welcome to our first MECI Alliance seminar of 2021. Um, Seeing some friendly names here, and really appreciate all of you joining us today. Today, it's my pleasure to introduce my colleague, Dr. Brian Anthony, who is the faculty lead for the MECI Alliance. He also happens to be an alum of the department, having received his master's and PhD under the advising of Professor Kamal Yusuf Toomey. He leads the Device Realization Lab in Mechanical Engineering and also manages to find time to be the Associate Director of MIT Nano. He is going to share today about some exciting industry-connected projects he's been working on with students this year, and upcoming opportunities to get involved. Without further ado, I'd like to pass over to Brian to get us started.
Teresa, thank you very much. And let me just share my screen here. Let's see, share screen number 1. There we go. Hopefully it's coming through okay. So as Teresa said, I want to share with you today a little bit about what we've been doing in the department, partially in response to COVID and supporting our community, our undergraduate students. But also I think we're learning some things where there are some things that will stick post-COVID, and want to share with you opportunities for both students and for industry partners to work with our students. So I'm giving this talk today, but really it's sort of on behalf as well, with a not the exhaustive list. And I'm sure I missed a couple of folks here. Certainly new students that are getting involved, but on the right is a list of the first cohort, if you will, of our undergraduate students that span from freshmen to seniors that are heavily engaged in a project by themselves, or potentially a group of 2 or a group of 3, but on a project that has been articulated, at least in part, and sometimes quite heavily, by industry colleagues that have a particular challenge or an open innovation problem. So industry connected projects and learning opportunities I'll share with you today for the next 30 minutes or so. So the context, as we're all living in the COVID environment, is our undergraduate education in the fall and certainly continuing in the spring, largely online and virtual, but we have a very real and very distributed community. So we asked the question, how do we, in addition to our classes and the other online things that are happening, what can we do to foster additional sense of community and opportunities for our students? So one of the things that came out of that, and partially the Institute at large, provided some funding for experiential learning opportunities. So I will maybe make the mistake sometimes of calling them ELOs or UROPs. In the context of what I'll talk about today, we're talking about projects, research projects that look like UROPs, but fit under the larger umbrella of a set of opportunities that MIT, through the various departments, labs, and centers, made available to our students. And those projects could be societal need, they could be research in nature, they could be teaching in nature. The projects that I'll share with you and talk a little bit about are the ones that are more research oriented, or sort of translation research oriented. But there's a massive push to make at least one experiential learning funded opportunity available to all of our undergraduate students. Now, through the department, we decided, based on our company networks, to try to define some projects that would be of interest to our mechanical engineering students, and that would have a relative ease, given the remote nature and distributed nature of the community, to be accomplished in this remote environment. So things that required a lot of lab work probably wouldn't be good fits. So what we settled on are looking at sort of data science and simulation and modeling, data analytics and machine learning in mechanical engineering, in design, in manufacturing, in process control and systems control, and folding in obviously some of the other aspects that you need to be a professional working in a distributed environment and distributed community. But so mechanical engineering plus data, or so simulation, modeling, computation. the activity that we went through has worked with a lot of company partners. Some of you are on the call today, and if you would like to get involved, please let us know after this and send us an email. But we defined projects, and that's mainly what I'll share with you today. Projects that were informed or motivated by your problems, meaning industry problems, particular companies' problems, or particular industry-wide challenges, but very much the challenges and opportunity that a particular company has. And then advertised those projects broadly to the MIT community, focused on the mechanical engineering undergraduate population. And students that raised their hand to express an interest in the various projects allowed them to form either individual groups or up to a group of 3 to work on the project. The framework is each project, each student has both an MIT advisor and industry professional supervisors, collaborators that, depending on the nature of the project, they can reach out to once a week, twice a week, maybe it's once a semester, but to have that industry context and the opportunity to get that professional perspective, industry perspective on the challenge that's been articulated and what they're trying to accomplish. Now, in addition to them doing their individual projects, one of the opportunities is to say, well, I may be doing a project in machine learning applied to process control, or I may be doing a project in trying to improve how we control a robotic arm, or doing data analysis on a coffee grinding process. There are some common attributes across all of these projects in the nature of the simulation and modeling and design and the tools, whether it be MATLAB or Python, or understanding the frequency domain or understanding principal component analysis. But to identify the common themes or the common learnings that would be helpful to all students on these projects, and to bring them together as a cohort once a week, once every other week, so that they could share the progress that they're making on their individual projects. They could get some educational nuggets that would help them execute their various projects, and to provide some common learning, common support activities, and to really foster this community that's so important in general, but even more important in the environment that we're all in today. Now, from an industry mentor or an industry sponsor perspective, the way that sort of you want to think about this is, do you have open innovation project ideas that are particular problems that you would like to get a handful of bright MIT students, pondering over and working on? Would love your advice and mentorship, both in defining the project, but periodically meeting with students. Participate in some way in the midpoint review and the final review to give context and feedback. Again, that mentorship role. And then, as your availability allows, I would love to get your expertise and have you give a 1 hour or a 2 hour or a 2-session talk or discussion on a particular area where you are an expert or feel that you're very experienced and want to share that experience. It can be on communication, on time management, or a technical aspect of a project, or leadership. And then certainly looking for sponsorship. In the last semester and over IAP and during the spring, MIT will continue to offer central funds for some of these projects, but we can augment them, expand them, and allow them to have greater impact with, in addition to your time, if you're able to contribute a little bit of money to the UROP scale project. So it's not a lot of money, but just a little bit goes a long way in being able to sort of help everybody in this particular challenging time. So the participating students, again, sort of 1, 2, or 3 in a particular project, weekly meet, bi-weekly meet with their advisor and company supervisor, engage in these cohort-wide activities, and make good progress on what it is that they're doing. So that's the framework. Okay. So if you're excited to say, okay, Brian, you've told me a little bit now. Okay, well, what are the projects? How do I get involved? Give me some examples. Let me share some examples. I'll have one slide on each project. I chose not to put the names of these students that are currently on these projects. On all of them, we have at least 1, sometimes 2 or 3 students. These projects are still available. They're big enough that even if we have a student or a group of students working on an aspect, there's plenty of work to go around, and we can define additional components for these projects that we've already defined in collaboration with the various partners. So one project is sort of very a design-oriented project, design the interior of the car of the future. Once we have completely autonomous vehicles and we don't need to be sitting in front of the driving wheel, what does that car look like? Is it a place for entertainment? Is it a place for healthcare? Is it a place for relaxation? But in any of those use scenarios, what's it take to manufacture it? How much power does it take? What are the design choices and trade-offs? And so there's a sort of a set of students that are looking at, just unencumbered, take a look out 5 years, 10 years, 15 years out. What does that car of the future look like? And what would the manufacturing process? What are the design constraints? What are the power constraints to get to that point? That's a design-oriented project, sort of a conventional, or so not a conventional, but sort of a design of a future state. Another, I think, very interesting project is looking at the design of a very low Earth orbiting constellation. In particular, the students on this project are inheriting, if you will, a number of different open source packages that allow them to simulate communication for given constellation structures. How do the different constellations that are envisioned to be commercially available communicate with one another? And how do you have continuous coverage? And so what's the communications protocol? What's the network look like in order to have a sort of a set of constellations out there that can communicate with the planet, but amongst themselves? Coffee roasting. How do we, a great example, measure the recipes that are used for the roasting of coffee beans, the temperature, pressure profiles that go through in the roasting process. And that's going to produce, based on sort of an input quality of the bean, it's going to produce a certain output quality of the bean with measurable characteristics. So develop the characterization and the models that connect the recipe and the bean input to what the bean is going to be like at the very end. And can we model it and predict that, use it for process control, use it for improving the quality of the bean? A similar in nature project, looking at, in this case, the optical or drawing, extruding of fiber, and whether that be optical fiber or polymer fiber. How do we apply some machine learning tools to characterize the as-built process? And then how do we use those models of the as-built process to innovate in the control systems, to do something a little bit more rich than PID, sort of conventional proportional integral derivative controller, and to have both a physics-informed model that's augmented with data, and then use those combined data and physical models to improve in the performance, the quality spec of the tolerance on the produced fiber. Non-contact vitals. So in the context of the home, and there's been a lot of work both at MIT and places around the world, but how do we deploy non-contact or ambient sensing technologies into the home? In particular, how do we use radar? And a little bit of foreshadowing, next week you'll hear, if you could join us next week, a little discussion around how these technologies have also been deployed on campus to measure vital signs in a non-contact way. But using things like different radar modes, you can, whether it be continuous wave or frequency modulated, you can tease out the reflecting properties of the human body. The human body is moving as it's breathing, as the heart is beating, and you can start to tease out things like the heart rate and the respiration rate. So developing both the simulation tools and some of the algorithms that allow you to extract that information from the data. This is a sort of maybe one of the future users of this project would be Amazon, with sort of flying drones with arms. But this is before you can stick a robotic arm on the end of a UAV, a flying delivery vehicle, you need to have a good design and simulation tool to deal with the coupled dynamics between a robotic manipulator and a vehicle that's still flying before it's landed and potentially is trying to deliver a package. So looking at developing some of the MATLAB from MathWorks, the MATLAB toolboxes that allow the joint modeling and simulation of the coupled dynamics between a robotic manipulator, which typically sits on the ground, and a flying quadcopter in this image, for example. And this, use that to inject that development into future toolboxes that are made available for people that are trying to do simulation, modeling, and design of flying UAV controlled arms. There's been a lot of interest from our students in image processing and video processing. This particular project is looking at underwater imaging, both in detecting contaminants and quantity of dirt in water, which is represented by the top image, and in the bottom, being able to take underwater video streams of fish that are going through a fish ladder and automatically counting and tracking the species of fish and counting the number of fish for being able to control and monitor the fish hatcheries and the fish farms. Related, sort of on the image processing side, a project that looks simultaneously at both a manufacturing challenge and a medical challenge. And the challenge is, how do you quantify and interpret flexible, deformable, large planar structures? And that large planar structure could be the skin. And that's maybe this image that you see up here with the vasculature of the skin, or the microrelease of the skin. So your skin is this stretchy thing, and features move if you stretch it around. And there are things like the microreliefs or cancerous marks that may show up, and you want to track those and track those over time. But similarly, if you are producing flexible electronics, where you're printing on a flexible substrate and you want to print patterns on that flexible substrate, and you want to be able to register one print pass versus another, you need to have a way to acquire an image and understand how an image is being deformed, meaning how the material is being deformed, so that you can register and track changes in that deformed substrate over time. So developing the image processing techniques, and then how you use information from those image processing techniques to develop a controller and a control system. Now moving for a little bit on some more maybe simulation approaches, so FEM and or CFD type things, but being able to analyze and predict the water evacuation from different tire treads and different designs of the sides of how water comes out from underneath the tread on a tire. So a little bit of fluid flow modeling and simulation mechanics, and we didn't get yet to the point where this project had data from an experiment. We're still waiting on that, but being able to make progress on the simulation and modeling has been interesting to observe. Related to this, another sort of tire project looking at how tires are fabricated and characterizing and modeling the multi-material fabrication of the tires, how different materials and under different processing techniques can adhere or not, and developing the simulation tools and use those to compare to data from the actual manufactured and characterized processes. Another sort of really interesting on the image processing side, and as you'll see, that's a recurring theme through a lot of these. And just a couple more to share. This is now using sort of imagery of welds, laser welds, and developing imaging micrometry tools to measure key parameters of the weld. Is the weld there? Is there a defect? What's the depth? What's the height? And so being able to automatically characterize what are the key dimensions, and also be able to automatically determine if the weld is of an appropriate quality. medical data classification. So this is a classification problem where the data comes from imagery, features from this was not sponsored by a company. This was sponsored and recommended by a doctor, local doctor, where they get particular features from an image, the radius, the diameter, the sort of the texture of different cellular features in the image, and then developing based on a biopsy, and then developing a classifier that allows us to predict whether or not the cell sample is from a cancer cell or a non-cancer cell. So things like support vector machines and logistic regression, but conventional sort of classification tools applied in a medical scenario. Then we have scenarios like this one. This is some production data from a machine that's a cutting machine that wraps foil or plastic as part of a packaging process. And the need that the students worked on is developing a technique to do condition monitoring based on the IoT data, based on the production data. So things like the torques and the velocities of how material is moving through, to be able to predict based on that production data, the wear profile of components that were not monitored or not sensed, right? There's a blade on this machine that couldn't be directly measured, that's buried inside of the machine. But the torques and the velocities that are used in the manipulation of that blade change over time. And so there is a buried signature in the condition and the health of that blade that's monitorable. A similar project, but instead of looking at a blade on the production line, looking at the condition of offshore structures, and looking at the machine learning and data analytics techniques to quantify vibration data and monitoring data to understand the health, the condition and health of large structures that are exposed to rather harsh environments. And then the final two projects that I'll share, actually, we just got, these are just getting launched, these next two, a student just joined each one of these. This first one is looking at off-highway vehicle tire modeling, to be able to add and augment the virtual representation of a tractor or other off-highway vehicles in a virtual environment, so that you can get both the mechanical feeling of the vehicle and the noise of the vehicle, but the relative stiffness and sort of the interaction of the tire, the rigid tire with different ground medium, whether it be soft dirt or wet dirt or mud, and being able to develop those models and incorporate them into a full virtual vehicle representation. And then the final project that I wanted to share with you is on vehicle sound modeling. Again, this is of off-highway vehicles, but to augment both the visual and the mechanical representation of a vehicle in the virtual environment, being able to have appropriate sound reproduction of the way that the engine sounds, or within the way that the engine sounds when something is wrong or when it's under strain. So developing, some simple sort of modeling tools, first characterize the sounds coming from different engines and use that as a data-driven tool that couples with some of the underlying physics to develop a both physics-based and data-driven approximation to the sounds coming from a vehicle during operation. So what did I want to do today? I know that was a very fast sort of overview. I wanted to sort of share with you, these are, if you're a student on the call today, these are opportunities. All of these are projects and opportunities that are available. So if you're interested, reach out. Even if they've been started in some way, they're all rich enough and have very multiple facets that I think will be intriguing for you both to learn, that could serve as the basis for undergraduate theses or just undergraduate projects, and at the same time, get you connected with other students that are doing all of these projects so that you can form an expanded cohort, an opportunity to learn and share with each other and learn from each other. Now, if you're a professional, whether you be a doctor or working in a company or sort of a faculty member at MIT, and you have connections with such folks, the idea here is to have these projects not just be projects that are coming out of our labs at MIT. Those are wonderful projects. But part of the premise here is that we want these projects in some way for this sort of cohort of industry connected projects to really be informed and fueled by industry problems that gives us an opportunity to help our students find jobs, to sort of establish connections with particular companies, particular individuals that could lead to employment opportunities. And we're looking for your ideas, your open innovation ideas, the problems that you think that are of a similar scale and scope for some that I just very quickly outlined today. We want your projects. We also want your mentorship. We want to build this as a community that allows us to, through this vehicle of undergraduate students doing these projects and interacting with professionals that are on the call today, grow these as opportunities, both for you as individuals, the students, and people that may be wanting to employ and hire you. But I think we'll see many of these different aspects of these projects can grow and turn into a larger opportunity, whether it be for a master's thesis for a particular student or a larger project that a company is potentially interested to fund as sponsored research. So what we're looking for, though, is quite simple. We're looking for students that are looking to do interesting projects that have an industry flavor, that have an industry context, that are motivated by problems that people are trying to solve now, that can lead to sort of furthering your understanding, that can lead to getting engaged with people that may want to hire you, that'll get you engaged with other students that are working on a similar set of projects. We're looking for mentors. We're looking for professionals out there that can help define projects that beyond the definition of projects, and we do that collaboratively, but that have a little bit of spare time to serve as an additional mentor, and again, as your time allows, to once a semester, once every so often, come in and share a little bit of your experience and expertise, whether it be technical, professional, project management, what have you. But again, to build this cohort of connectivity between practitioners of engineering and students of engineering. And always and certainly welcome program support beyond what MIT is able to provide. We have a finite number of these opportunities that MIT has graciously helped us to foster. But I think this is one of the things I am particularly excited and intrigued by, and we'll see how this plays out. But I would love to continue aspects of this post the COVID time. And I think we're learning how this works. We're sort of completing our first semester cohort of this idea of having not a class, but this cohort of people that are working on a project. And it's been very powerful in figuring out both how to teach to that, to convey, well, what are some of these common educational nuggets, like the Fourier transform and frequency domain analysis, or sort of simple modeling tools, how you go about thinking about a control system when you've just inherited a system. How do you tease out what's wrong and think about innovating? And those kind of questions, the engineering challenges show up in a lot of these projects. And so we're seeing a lot of really interesting cross-pollination. So I'd love to entertain both larger engagements and companies that can either now or in the future help to support the growth and evolution of this project or this program once it's beyond what the Institute's response is to help everybody in this particular challenging time because of COVID. Okay, so with that, I wanted to do this in about a half hour, so we had plenty of time to discuss and chat, and I see that I did that. But happy to take questions and comments, and I'll turn it over to Teresa to marshal this.
Great. Thank you so much, Brian, for this useful overview. I see some of you have already found the Q&A window, and thank you for doing that. If you have a question, please do enter them. To get started, a really great question, especially in the industry context. What is the IP? What are the IP considerations both for students and companies participating in this program?
Yeah, great question. So this is not sponsored research. the same IP rules that apply to a student in a class at MIT apply, meaning if they're inventing something, that they own it. And so that's, we're not looking for this program for things that would require an NDA or that where you're hyper concerned about the IP. So yeah, excellent question. There are other ways to do things for which you have more of an IP concern or constraint. But here the inventions are going to go to the people that invented them, and that can be the student, or it could be, if you've done it collaboratively with the student, then that's that's co-ownership. But the model for how the IP works is the general model for how a student, if they invent something in a class, that's the model that we follow here. So thank you for that question.
Next question is, how much familiarity or experience in the project content is expected of students interested in participating?
Yeah. Thank you for asking that. We have the full dynamic range, meaning we have students that had no experience whatsoever that were just really enamored and intrigued by the project. And you're jumping into the deep end, you're drinking from the fire hose, whatever analog you would like to use. But that's okay. And I think the main point is, if it's a project that you're intrigued by, you're going to be motivated. There is no expectation that there's a sort of a particular deliverable that you're trying to hit. It's predominantly a learning activity. We would like you to sort of contribute to the forward evolution of the project, but it's okay for it to be a learning activity, and both learning of the tools that are required and learning even how to approach the problem. So we're not going to turn you away as a student if you say, hey, you know what, I don't know enough about MATLAB or Python or sort of Bode diagrams if I'm doing feedback control to do this. Like, we now, what's been exciting and interesting is we have probably 10 little educational nuggets that we've developed that are sort of pieces that are both very practical in nature, that help to sort of accelerate your learning curve. So a little bit on MATLAB, a little bit on Python, the basics of control systems, not a full class on control systems, but here's enough to get you started. Here's what it means when you're talking about sort of the big picture of control systems, or the big picture on Fourier analysis, or the big picture on image processing. So we've developed now not the full set of what we may need in the future, but I think for somebody that is coming at this fairly new as a freshman or from a different set of backgrounds, I welcome your engagement, and I think that's be excited to have you on board.
Thank you, Brian. Those are the questions that have come through in the chat. If anybody else has any final thoughts or questions. Okay, great. Good question from Albert from Blaze Tech. Are students getting credit for the project or any grade?
Great question. So these are if we go back, so these are all framed through MIT currently as these things that we're calling ELOs, experiential learning opportunities. But they, in practice, for the research aspects, are very much look like a UROP project. And for the most part, the students are getting paid. They get sort of an hourly, and the expectation for the student during the semester is probably about 10 hours a week. During IEP, they sometimes have the availability for full-time during the IEP period. But most students are taking the pay. And that was one of the reasons that MIT decided to offer all these different opportunities, to recognize that finances were particularly challenging under the COVID environment, and work study programs, and sort of you couldn't work on campus if you weren't on campus. We have had a few students though that have chose I'll call it the conventional alternative route for UROPs, and to take a letter grade. But they are most students are choosing to get the pay for it. Which is why sort of sponsorship can help, and because it is right now MIT is footing the bill. That will need to change in the near future.
Great, thank you, Brian. Really good question. Can we access your slides of sample projects to share with others who may be interested in considering this opportunity?
Absolutely.
Yeah.
And I believe all of the projects that I listed here are also available on the MECI Alliance webpage. And I don't have that link right in front of me.
I'll put it in the
Teresa,
chat
maybe
while
if
you
put in the chat, that'd be great. And so the first answer is yes, we'll make my slides available, but I don't think you need them because everything in effect is on the MECI Alliance webpage. And they can be found as well. And they can be found as well advertised on the UROP webpage as well.
Great. I just put that website in the chat. But I happen to know the person who, or know at least how to contact the person who asked specifically. Anybody who would be interested in receiving the slides is welcome to email me, and my email was in Brian's final slide, teresaw@mit.edu. And you actually did answer the next question. So yes, these projects are currently posted on the UROP job board. So for students, you will probably be familiar with that. And then the full details are on the website that I just put in the chat.
And you know, the timing is right now. We would like to get posted new opportunities. So these opportunities are still available. I'm in conversations with a collection of companies now to get new projects defined. Please add yourself to that list. I would like to have I'd like to advertise and work with you to define your project and get students excited and partaking in it. So if you have a something that is, even if it's not fully baked and you want to chat through it, send me an email. Do copy Teresa. She'll make sure that I, in my flurry of things, don't miss it. And we'll work with you to define sort of a thing that's at the appropriate scale and get it up there for people to engage with.
So I'm going to go ahead and pull up our closing slide, but feel free to sneak in a final question if you have them.
So thank you everybody for your time, and look forward to look forward to your ideas, and if or if you're a student to sort of applying and joining the crew.
Definitely. So tune in next week. Next week we'll actually be hearing from a few of Brian's students to learn a little bit more about some of these COVID solutions that they've been developing and deploying on campus. If you're interested in finding more information about future seminars, you can join our email list. We send one email a week just with the upcoming seminars. And we also have a brand new company page on LinkedIn where we'll also be posting those as well. And I don't see any more questions, so I just want to thank you all for your time today, and I hope you have a wonderful day. Thank you.
Thank you, everybody. Thanks, Teresa. Thanks, Irina.